Good afternoon. I would like to present to your attention our work entitled Selection of Deep Reinforcement Learning Using a Genetic Algorithm. Observing the process of learning in the nature, we can see that the success of the body's adaptation to the environment depends on the several factors. Conventionally, these can be depicted using the so-called learning success pyramid, which is shown on this slide. The basic factor in this is the process of evolution based on the natural selection of the best individuals from the population and combining their properties with each other to create even better offspring. This process allows to weed out the individuals who have adapted the worst to the current conditions. This is the process when ancestors directly influence the propensity of descendants to learn. The next layer in this pyramid is the process of self-learning. Based on the qualities received from their ancestors, an individual may have a greater or lesser inclination to learn and accordingly show learning outcomes. This is a process where each individual is responsible for himself, when each needs to explore the environment independently and make its own decision based on observation. The top of the pyramid is the process by which more experienced individuals pass on their experience to less experienced ones, the so-called learning process with the teacher. In this paper, the combination of the first two layers of this pyramid will be investigated, namely, the process of selecting the best adapted individuals using a genetic algorithm and, in fact, self-learning algorithm based on deep reinforcement learning. Consider in more details each of the stages. Genetic algorithm is an artificial simulation of the process of natural selection, creating a population in which all individuals have minor initial differences. With each generation will produce offspring those individuals who are best adapted to the condition of the environment. The better individuals adapt to the environment, the more likely they are to have more offspring. Reinforcement learning is an artificial simulation of the self-learning process. It is based on the observation of the agent of the environment and based on this observation and the results of its own previous actions to determine which of the possible next action will be most useful in the current situation. Nowadays, there are a significant number of possible implementation of deep reinforcement learning algorithms with sometimes it could be difficult to determine which of the algorithm would be best used to solve the issue. In addition, each algorithm contains a number of initial parameters that affect its performance. Some parameters may improve the result, some may worsen. Sometimes the parameter can only affect the speed of the algorithm or its own learning. In this experiment, the parameters of this deep reinforcement learning algorithm act as artificial genes or chromosomes for the genetic algorithm. Since deep reinforcement learning algorithms are often not interchangeable, was decided to isolate the population of each of the algorithms separately. These populations are considered separately during training, but during the selection based on generation testing, agents from all populations are considered together. This will allow choosing the best deep reinforcement learning algorithm for the current task. Consider in more details the flowchart of the algorithm. The initial population is created firstly, as shown in the previous slide. Next, the number of iterations is determined, or whether the quality of training or another desirable parameter of the end of the experiment. After the process of training, each agent model from the entire general population begins. Upon the completion of the training, testing, and conducted in virtual environment, in the result of which there will be selected the best individuals who will receive the ability to have offspring. If the criterion of completion of the algorithm has been reached, these selected individuals will be presented in the list of results. If not, a population of offspring will be created on their basis, and the algorithm will continue to work on the training of offspring. In the experiment, the agent's task was to balance the object on the platform for as long as possible. You can see how with each succeeding generation horizontally, the average balancing time of an object gradually increases. The criterion of completing this experiment was a number of iterations of the algorithm. From the initial total population of 30 individuals, by the middle of the experiment, the population had halved and the best algorithm was chosen. The process of improving the initial parameters in this algorithm continued. At the end of the experiment, the 5 best options for the initial parameters were selected. The advantages of this approach are ability to find the best general algorithm and the best parameters for it from the original population. However, the disadvantages include high hardware requirements and the significant time to find the optimal solution. Also remains the uncertain efficiency of the selection of algorithm due to the impossibility of crossing between them. And that's all. Thank you for your attention. Maybe you have any questions.